Welcome everybody to this lecture. In this lecture, I would like to go through a case study where you should act as a bank manager and you should optimize the operations of one bank. You can see here the structure of this chapter. So in the first step, we'll do a regression analysis. Afterwards, we'll talk about the assignment questions. We'll talk about a formal solution, a graphical solution. We'll do the bookkeeping and create a balance sheet. And afterwards, we will use the Excel solver to come up with the same solution as in the formal part or the graphical part. Let's have a look at the setting. You are the manager of Chase Automotive Credit Department, and Chase is competing in a banking market with 9 other banks, and each bank sets its own interest rate in the automotive credit market. The bank manager performed a market survey and collected data on the interest rate and the quantity of the automotive credit sold by each bank. So, like for example, Bank1 set an interest rate of 15% and the quantity is equal to 0. Bank2 set a slightly lower interest rate, 13.2%, and the quantity was positive. So it seems to be the case that the first bank set its interest rate too high and therefore no customer demanded automotive credit. There are other banks in the survey which, for example, set the interest rate to 12.4%. Bank number 10 set the interest rate to 12.4%, and they were able to get 23 quantity units. So some customers showed up and demanded this automotive credit. So it seems to be the case that when the interest rate is too high, not too many customers show up, and when some banks lower their interest rate, then more people arrive. Let's have a look at the assignment questions of this part. Analyze this data set graphically in Excel and create a scatter diagram. Horizontal axis, you should have the quantity. Vertical axis, you should have the price, like the interest rate. And then you should perform a linear regression analysis in order to gain information about the functional form of the demand for credit relationship. You should round the number to 1 digit, so 14.06 is equal to 14.1. The solution will look as follows. We have here one diagram where we have the interest rate on the vertical axis, the quantity on the horizontal axis. All these dots represent one bank. So for example, here we have bank number 1, which set the interest rate to 15%, and no customer showed up in this bank. The quantity sold was equal to 0. Furthermore, you can see here this regression line. The regression line has the following characteristics: that the y-intercept, the intercept with the vertical axis, is equal to 15. And then when you go one step to the right, the curve goes 0.1 steps down. Or when you go like 10 steps to the right, the curve goes 1 step down. So like we have the usual demand relationship, that the demand curve is downward sloping. Let's have a look at the Excel sheet and try to replicate this graph. In this Excel sheet, you can see all the information. Like for example, here is Bank 1 with an interest rate of 15% and the quantity is equal to 0. How can we perform this scatter diagram? We have to mark the area. Like all the area with the data has to be marked. Then we go to Insert, Einfügen, and we look for the Punkt XY diagram or XY scatter diagram. So please don't use a line diagram, it has to be a scatter diagram. Then we take here the first diagram, Punkt XY XY scatter diagram, the first one. Afterwards, like we want to create some labels, and we also want to run this regression. So this is very easy because there is a fast layout, Schnelllayout, and when we take layout number 9, like third row, third column, then you are able to add some titles for the axis, and you also get the regression relationship. So let's delete this one here. Let's delete that one. We can move it to this area here and make it a little bit larger. We can also format the numbers if you want to. So we want to have only one decimal point. Okay, and then we have to write something to the axis. So this is the quantity, and this is the interest rate. So now you are done already, and I'll switch back to the slideshow. So here, once more, you can see the solution, a scatter diagram with a regression analysis, and you get the information about the demand relationship. Let's go further in our case study. Let's come up with some assumptions for this automotive credit market. Private consumers are borrowing money to buy a car. The duration of the loan is 5 years. The consumers pay back loan in a lump sum after 5 years. The demand relationship for the automotive credit market is given by the interest rate, PA, is equal to 15 minus 0.1 times the quantity. So in this first equation, PA symbolizes the interest rate, the price in the automotive credit market, and A symbolizes the volume of the automotive credit market. Let's have a look at some further assumptions. The liquidity which is sold in the automotive credit market can be bought in the money market. The interest rate in the money market is constant, so the money market interest rate is equal to 5. On the next slide, you can see some information about the question, what is the money market? I'll not go into detail, but I'll come up with the assignment questions for this part. So you should solve the profit maximization problem formally. You should come up with an answer to the question, what is the optimal interest rate and what is the optimal credit volume? How large are profits? You should solve the profit maximization problem graphically. And in a third step, you should also create a bank balance sheet at the beginning and at the end of the year. In a fourth step, you should cross-check your results by using the Excel solver. Let's in the first step have a look at the profit function. The demand for automotive credit is given by the interest rate is equal to 15 minus 0.1 times A. The money market rate is equal to 5. The profit function is always revenues minus cost. It makes sense to write this down because it's so important to clarify what are the revenues, what are the costs. The overall idea of the bank has to be buy liquidity at a low rate and sell liquidity at a high rate. So the bank wants to buy liquidity in the money market at a low interest rate of 5, and they want to sell this liquidity in the automotive credit market. So the revenues, they stem from the automotive credit market, and the cost, they stem from the money market. With this information at hand, we are able to define the profit function. the revenues are given by price times quantity in the automotive credit market, and the cost, they stem from the money market, the interest rate in the money market times the quantity in the money market. When we plug in all the information we have, we get to equation 3. In the first part, we have insert the demand relationship. This stems from our regression analysis, and when we multiply through the price times the quantity, we get our revenues. Furthermore, we have to subtract the cost, so 5 minus m, this is the cost part. We can get rid of the brackets here. We multiply through 15 times a and minus 0.1 a times a, and we get 15a minus 0.1 a squared minus 5m. Under consideration that the quantity which we are buying at the money market has to be sold at the automotive credit market, we get to equation 4. The profit is equal to the revenue part, which is given by this part, and then minus 5a, which stems like from the money market, which represents the costs. So the profit function is given by this relationship, and then we can compute the first derivative. The first order condition is that the first derivative has to be set equal to 0, so we have to differentiate the profit function with respect to a. We get 15 minus 0.2a minus 5, and this has to be equal to 0. So more or less, we have here in equation 5 marginal revenues, the green part, minus marginal cost has to be equal to 0. Or when you want to put marginal cost on the other hand side of the equation, we once more have the typical profit maximization condition that marginal revenues have to be equal to marginal cost. In the next step, we can compute the optimal price and the optimal quantity. So in the first step, we determine the optimal quantity. So we combine the 15 and the 5 minus 5. We get a minus 10. We get a 10 on the left-hand side. And then when we put this minus 0.2a on the other hand side of the equation, we get 0.2a on the right-hand side. In the next step, we divide by 0.2 so that we isolate a on one hand side of the equation, and hence we know that the optimal quantity is equal to 50. Now it's very easy to compute the optimal price. We have to insert the optimal quantity into the price relationship, and then we get here that the optimal interest rate is equal to 10. What about the size of profits? We can insert the information we have in the profit function. So price times quantity, the price in the automotive credit market times the quantity. This is equal to 500. And then we have to subtract the cost. The costs are 5 times 50 minus 250. So the profit is equal to, revenues are equal to 500, costs are equal to minus 250. The profit is equal to 250. Another possibility to compute the size of profit is that we compute the profit per unit first, and then we multiply it through by the units. So this formula is the profit is equal to the profit margin, the interest rate in the automotive credit market minus the interest rate in the money market times the quantity. So 10 minus 5, the profit margin is equal to 5, multiplied through by the quantity of 50. So we get a profit here of 250. So the profit is equal to 250 cents, or like €2.50. This is important that we do this last step because of the fact that, of course, like this is an interest rate of 10%, this is an interest rate of 5%, so profits will be equal to like 250 cents or 2 euros and 50 cents. We have to consider the dimension. In the next step, we were asked to perform a graphical solution of this problem. In this graph, you can see 3 different lines. On the vertical axis in this diagram, we have once more the interest rate, and on the horizontal axis, we have the volume. So we are working in a typical price quantity diagram. Then you can see here the 3 lines. We have a blue line, which is the demand relationship, which stems from the automotive credit market. It starts at 15, and then it is a case that it has a slope of minus 0.1. The red line here, this stems from the money market. It is the interest rate on the money market, and the interest rate on the money market is equal to the marginal cost. So the red line symbolizes the marginal cost. In case that we have a linear demand relationship, it is the case that the marginal revenue curve will start at the value of 15 and will have 2 times the slope of the demand relationship. We can see it on slide number 12. The green part is the marginal revenue relationship. It starts at 15, but then it has 2 times the slope of the demand relationship. So the slope of the marginal revenue curve is minus 0.2 times A. Let's go back to the slide. So the green line, this is the marginal revenue relationship. In the first step, we have to find the intersection of marginal revenues with marginal cost, which is here. This is the point where marginal revenues and marginal costs are identical. So we get here the information that the optimal quantity is equal to 50. And after we have computed the optimal quantity, we were setting the optimal quantity in the demand relationship, so in the blue line. And then we got the information that the optimal interest rate is equal to 10. So the optimal solution is, we are looking for the intersection marginal revenue and marginal cost. We find the optimal quantity of 50. And when we insert the 50 into the demand relationship, then we find here the optimal interest rate of 10. In the next step, we were asked to come up with a balance sheet. Therefore, it makes sense to, in the first step, clarify what are the assets, what are the liabilities. We can distinguish the assets in short-term assets, long-term assets, and on the right-hand side, we can distinguish short-term liabilities, long-term liabilities, and equity. Of course, it will be the case that the automotive credit goes to the left-hand side, to the asset part, and the liabilities, they will consist out of the money market operations. The overall idea is to buy low, sell high. So the assets should have a high interest rate, while the liabilities should have a low interest rate. Only then the profit margin is large and our bank will make a huge profit. So in case that the asset interest rate is high and the liability interest rate is low, this secures that the profit is high and the dividends for our shareholders is also high. So let's start with the balance sheet in year t equal to 0, like directly after we performed this optimization problem. It is the case that we have on the liability side the 50 units of where we bought liquidity at the money market at the interest rate of 5%. This goes to the short-term liability side, and then we are selling the liquidity in form of automotive credit at an interest rate of 10%. And here you can also see the volume of 50. This is the balance sheet like 1 minute after we performed this deal. How does the expected balance sheet look like in 1 year from now? In 1 year from now, we expect like a 10% cash flow from the automotive credit market. So we expect revenues of €5 from the automotive credit market. We have to pay at the money market €2.50 because we are borrowing €50 at the interest rate of 5%. So we have revenues of €5, cost of €2.50, so that the profit is €2.50. It will be the case that we have cash inflow of €2.50 here, which ends up as a short-term asset. And also on the right-hand side, equity increases by €2.50. This is like the first part, and we solved all the questions so far. But now we can do a short sensitivity analysis. For example, we could ask ourselves, what happens if, always compared to the basic scenario, what happens to the expected balance sheet in case that 1 day after t equal to 0, 5% of the car users have an accident, the car is totally damaged, and the private consumer is dead. We have non-performing loans of 5%. So how does the bank balance sheet look like when 5% of our customers have an accident? It will be the case that we have to write off automotive credit here. It will not be 50 anymore, but we have to write off 5% of our loans because they are non-performing. Furthermore, it is also the case that the cash inflow is lower than before. It is lower than before because of the fact that when our customers die in a car accident, they are unable to pay the interest on this automotive credit. So not only the long-term asset is affected, but also the short-term asset. Hence, it becomes clear that in the end, due to the fact that we have to write off automotive credits as non-performing loans and the cash inflow is lower, we'll make a loss. Our bank will make a loss, and the equity will be negative. How can we secure the bank against this kind of risk? Of course, one idea is that the owner of the car has a car insurance, and another idea could be a life insurance. So in case that our bank is selling an automotive credit, we can also think about selling car insurance, and we can think about selling a life insurance here. We call that cross-selling. We are not selling only one product, but we are selling 2 or 3 products which are related to the initial product. Another sensitivity analysis. What happens if it is always the case that 5% of the car users have an accident? How can the bank avoid risk? How does it affect the profit maximization problem? So we talked about the life insurance already. Another idea is that we incorporate the information that 5% of the car users have an accident in the profit maximization problem, and then we have to adjust maybe the interest rate in the automotive credit market. This is like another idea to solve this kind of problem. What happens if what happens to the expected balance sheet in t equal to 1 if the money market rate increases from the level of 5% on one day after t equal to 0 to the level of 8%, to the level of 10%, or to the level of 12%. Of course, when the money market rate increases to the level of 10% in scenario B, then the profit margin will be equal to 0. We are buying liquidity at 10% and we are selling the liquidity at 10%. So the profit margin is 0 and the profit will be equal to 0. What if the money market rate increases even to the level of 12%? Then of course the profit margin will be negative because we are buying something at 12% and we are selling it in the automotive credit market at the level of 10%. When the interest rate increases to 12% at the money market, we have a big problem because we are buying liquidity at 12% and we are selling it at 10%, so the profit margin is negative. So in this scenario here, it will be the case that we receive revenues of 5 euros from the automotive credit market, but we have cost of 6 euros in the money market. So we have a negative cash outflow of like 1 euro. We have no cash in our balance sheet, which can flow out, so we need to get more liquidity on the money market. Money market increases to 51 euros and the equity is negative here because we are making a loss. The equity is negative 1 euro. So we have to think about different types of risks here. For example, we have the counterparty risk. There are car accidents. We are dealing with wrong customers which are not able to pay back. We have no or a wrong risk premium. Furthermore, there is a risk because we finance long-term assets with short-term liabilities, and when the short-term liabilities, when the interest rate changes, then this might lead to a problem. Like especially when the interest rate on the short-term liabilities increases, then we have a problem because we have used this liquidity in a long-term contract. Then it might be the case that we have a rollover risk or prolonging risk. The market might dry out. We have financed long-term assets with short-term liabilities. So we rely on the money market to finance our operations. When other banks do not lend the money to us anymore, then we have a problem. Like we are relying on other banks on the liability side, that our bank has access to the money market and gets liquidity from other banks. In the last part, I would like to talk about the Excel solver. I'll once more switch to Excel in order to explain how we have to set up this Excel balance sheet. And we want to confirm that in the end, the profit in the basic scenario is equal to like 2.50 euros or like 250 cents. I just have set up this Excel sheet. It's the case that we have here the quantity of the automotive credit market, and in this cell number D5 I just type in a random number. So for example, I type in the quantity which is equal to 2. The cell D5 is called changeable cell, and in the end Excel will play around with the 2, change the 2 so that in the end the profit is maximized. The interest rate in the automotive credit market, we can use our magic formula, 15 minus 0.1 times the quantity. So now here the interest rate should be equal to 14.8. The revenues, this is the price in the automotive credit market times the quantity in the automotive credit market, so the product D6 times D5. The costs are equal to 5 times the quantity. 5 is the interest rate in the money market, and the quantity is equal to D5. So 5 times D5 gives us the cost. In the next step, we have to compute the profit. Profit is defined as revenues minus cost. So D7 minus D8, this is the profit. So right now, the profit is at 19.6, which is not optimal. Like we know that the optimal profit should be equal to 250. Now we can use the Excel solver to solve this problem. We go to Daten, Data, and then you find here the solver on the right-hand side of this menu. Perhaps when you have not used the solver before, you have to install it. So let's use the solver. Solve. In the first step, we have to define the objective. The objective is the profit. The profit is given in cell number D9. Then we have to confirm that we want to maximize it, so the dot has to be at the maximization problem. And then the changeable cell, this is cell number D5. D5 is the changeable cell. In the next step, I press Solve, Lösen, and it is the case that Excel was able to find the optimal quantity equal to 50. The optimal price in the automotive credit market is equal to 10. Revenues are equal to 500 cents. Costs are equal to 250 cents. And the profit is equal to 250 cents. In case that this was too fast, you can always go back to these slides and you find the formulas to set up the maximization problem on slide number 25. Thank you very much for watching this video. Thank you. Have a nice day. Bye-bye.